Quick review of graphing quadratics while in vertex form. When it's in vertex form, or we also call that transformational form, we can see right away where the vertex lies. In this case, it lies at 3, -7. One of the advantages of knowing where the vertex lies is we need that in order to graph. And so by placing our point at 3, -7 here, and knowing that our axis of symmetry is then at x equals 3, we know that our graph, we also know it opens up because it's a positive in front, +1. So we know our graph is going to go up like this. Now, there are a lot of different ways we can decide where the next points will be. But for now, we were using the 1a, 3a, 5a method by determining our a. In this case, our a is equal to 1. So 1 times a was then 1. 3 times a was 3. And then 5 times a was 5. And so we were able to say that as we step out once, it goes up once. As we step out again, it goes up 1, 2, 3 on both sides. And then as we step out again, it goes up 1, 2, 3, 4, 5 on both sides. And then we have a feel for what our graph is going to look like. So that's vertex form. Today, we're going to learn about graphing from a standard form. Okay, so to graph in standard form, we still need the same information. We need to find the vertex. That's going to be the same no matter what form we are in. However, it's not as easy to find the vertex when you're in standard form, which is ax squared plus bx plus c. We do have a formula to find the axis of symmetry, however. The axis of symmetry is found by putting the opposite of b over 2a. Now, here's the thing. With the axis of symmetry, if we remember, the axis of symmetry is the x value of our vertex. So already, if we can find our axis of symmetry, we already know our x value, and then we'll just have to find what our y value is. So let's take a look at an equation, ax squared plus 4x plus 3, for example. So first of all, let's define what our a, our b, and our c is. Our a in this case is 1, our b in this case is 4, and our c in this case is 3. So the first thing we're going to do is find what the axis of symmetry is. Again, x is equal to -b over 2a. So x is equal, in this case, to -4 over 2 times 1, or -4 over 2, or x is equal to -2. So now if that's our axis of symmetry, then we know our vertex right away is going to be -2 something. So how do we find that something? Well, for that, we got to remember our standard form, and we know that y is equal to ax squared plus bx plus c. So if we know that y is equal to x squared plus 4x plus 3, which is the equation that we're dealing with, and we know that x is equal to negative 2, we can plug our x back in, and we know that y is equal to negative 2 squared plus 4 times negative 2 plus 3. So y is equal to negative 2 squared is 4, plus 4 times negative 2 is negative 8, plus 3. So y is equal to negative 1. So our vertex for this equation is at negative 2, negative 1. Think about that for a second. Okay, so let's try another problem. This one's a little bit different. So for the expression negative 2x squared plus 3, identify the a, the b, and the c values. Okay, well, we remember that our equation in standard form is y equals ax squared plus bx plus c. So we know that our a is negative 2. But what we're missing is our plus bx term, because there's nothing with a single x. All that means is that our b is 0 because there is no bx term. And then our c, our constant, is 3. Now, to find our axis of symmetry, remember our formula, negative b over 2a for x. So x is equal to negative b over 2a. And in this case, since b was 0, we know that our axis of symmetry is x equals 0. Now, to find the vertex, we want to plug our equation back in. So we have y equals negative 2. We said our x was 0 plus 3. So negative 2 times 0 is just 0. So we end up with y equals 3. So our vertex, our x was 0, and then our y was 3. Now, we can decide whether our parabola opens up or down based on our a value. And since our a value was negative, you know that our parabola opens down. Okay, so let's zip through a couple more problems. First of all, we have y equals x squared minus 6x plus 9. So we determine our a, our b, and our c first. Again, remembering in standard form, that's y equals ax squared plus bx plus c. So in this case, our a is 1x squared, our b is negative 6x, and our c is 9. Of course, we only take the coefficients, we don't take the x, but I just wanted to see where you came from. Now, because our a is positive, we know that it opens up. So the first thing we do in standard form is we find our axis of symmetry, which is x equals negative b over 2a. In this case, our b was negative 6, and so negative 6, or the opposite of negative 6, would then be positive 6. And then on the bottom, it was 2a, so 2 times 1, or 2. So our axis of symmetry was x equals 3. Now to find our vertex, we just take the equation again, and it's y equals x squared minus 6x plus 9. And so I'm just going to plug in my x equals 3. So I have y equals 3 squared minus 6 times 3 plus 9. So I have y equals 9 minus 18 plus 9. And 9 minus 18 plus 9 is y equals 0. So my vertex is at 3, 0. Now I have a starting point. But again, I know it opens up. I know my vertex is at 3, 0, but I need to know more points so I know what the graph's going to look like. And so, although there is another method that we're going to talk about on Monday, today I want to talk about just the 1A, 3A, 5A method because you're more familiar with that. So here, we're going to say 1a, 3a, and 5a. And again, since our a is 1, then 1 times 1 is 1, 3 times 1 is 3, and 5 times 1 is 5. So now we're able to go and graph 1 out, 1 over, 1 more out, and then 3 up, 1 more out, and then 5 up. And since it's symmetrical, we know that it's going to look the exact same way on both sides of the axis of symmetry. And so now we have our graph. All right, one more problem, and we'll call it quits for today. So again, y equals negative x squared plus 4x minus 1. We know that our a is negative 1. We know our b is 4. We know our c is negative 1. Since our a is a negative number, we know that our parabola is going to open down. Our axis of symmetry, x equals the opposite of b over 2a. So in this case, negative 4 over 2 times negative 1. So negative 4 divided by negative 2. So our x, or axis of symmetry, is x equals 2. Now for our vertex, we're going to plug that 2 back into our equation. So we have y equals negative 2 squared plus 4 times 2 minus 1. You'll notice that whenever I plugged my 2 in, I did it in parentheses here because I don't want to lose that negative in front of the negative x squared. So now I have y equals 2 squared, which is 4, so negative 4, plus 8 minus 1. So what I end up with is y equals 3, which gives me my vertex at 2, 3. Again, we're going to use our 1a, 3a, 5a method to graph, but this time our a is equal to negative 1. So 1 times negative 1 would be negative 1, 3 times negative 1 is negative 3, and 5 times negative 1 is negative 5. So let's come over here and do our graph. We have 2, 3 as our vertex. We're going to move one step out, but this time we go down 1 because it's negative 1. We're going to move another step out, and we're going to go down 3. And then we're going to go one more step out, and we're going to go down 5. And so now we can sketch our parabola. Hopefully, all right, hopefully you guys understand a little bit more about graphing in standard form. No homework for the weekend, but we are going to come back Monday and have some practice with this. Enjoy your weekend.